Welcome to our expert technical training on responsible AI. Today we are taking a deep dive into the critical considerations for inclusiveness within artificial intelligence solutions. Welcome everyone to our expert technical training on responsible AI. Today, our main focus is on a critical pillar of ethical technology, the considerations for inclusiveness in an AI solution. As we build increasingly powerful artificial intelligence systems, we must recognize that these technologies have a profound impact on society. According to our official training materials, responsible AI is a framework used to describe considerations for building AI systems that include strict guardrails to mitigate the risk of harmful, illegal, or offensive content and behaviors. Microsoft defines 6 core principles for responsible AI: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. While all of these are essential, today we are dedicating our time to inclusiveness. The core definition of inclusiveness in this context is simple but powerful. The potential of AI to improve lives and drive success should be open to everyone. As AI developers, architects, and technology leaders, we have a strict ethical and professional obligation to strive to ensure that our solutions do not exclude some users. If an application is only usable by people with perfect vision, perfect hearing, and native language fluency, it is fundamentally flawed and irresponsible. Inclusiveness means actively designing systems that adapt to the diverse physical, cognitive, and linguistic needs of our global population, ensuring equal access to the benefits of artificial intelligence. By integrating these inclusive practices directly into the software development lifecycle, we build trust and create products that truly empower every single individual. From an architectural and coding perspective, building for inclusiveness means abandoning single-mode input and output paradigms. Instead of hard-coding your application to only accept keyboard text and only output screen text, your codebase must implement abstracted interfaces that can seamlessly route data through various sensory APIs, such as speech-to-text and text-to-speech services, dynamically adapting to user preferences. This flowchart maps the 6 core principles of the responsible AI framework. Notice how inclusiveness branches directly into 2 primary directives for developers: to actively empower every individual, and to intentionally prevent user exclusion through thoughtful architectural design. Let us dive deeper into the technical mandate of inclusiveness. The training materials explicitly state that developers should strive to ensure that their solutions do not exclude some users. In traditional software development, accessibility was often treated as an afterthought or a compliance checklist item, added right before deployment. In the era of artificial intelligence, inclusiveness must be a foundational design principle. When we build an AI-powered application, such as a generative AI copilot or a conversational agent, we are essentially building a digital assistant. If we only provide a graphical user interface that requires reading dense text and typing on a physical keyboard, we instantly exclude millions of potential users. This exclusion contradicts the very purpose of AI, which is to democratize capabilities and augment human potential. True inclusiveness requires us to leverage AI not just as the core computing engine, but as the interface layer itself. We must use AI to translate human intent into machine commands, regardless of how that intent is expressed. This means anticipating that users will interact with our systems differently. Some users cannot see a screen, others cannot hear audio responses, and some may have cognitive disabilities that make traditional navigation incredibly frustrating. As engineers, we must actively dismantle these barriers by incorporating specialized AI workloads, like computer vision for screen reading, or natural language processing for simplified summarization, directly into our primary application flows. In your application logic, implementing inclusiveness requires adopting a flexible, multimodal event listener architecture. For instance, when designing a user prompt interface, your code should not only listen for an on-submit event from a text box. It must also actively listen for incoming audio streams from a microphone array, process that stream via an asynchronous API call, and map the resulting text to the exact same backend inference pipeline. This diagram illustrates a truly inclusive architecture. User intent enters the interface layer, which is equipped to handle text input, audio streams, or visual input simultaneously. All paths lead to the central generative AI engine, ensuring an inclusive user experience regardless of the user's physical capabilities. One of the most powerful mechanisms for achieving inclusiveness in an AI solution is the implementation of speech-enabled interfaces. Our documentation highlights that voice-based interfaces provide a much more natural way to engage with AI software, and specifically notes that the ability to interact through spoken language can significantly increase the accessibility and inclusiveness of applications and agents. By leveraging Azure Speech Services, developers can transform rigid, text-heavy applications into dynamic, conversational experiences. This is not just a convenience feature, it is a critical inclusiveness requirement. Consider users with severe mobility challenges who cannot easily operate a mouse or a touchscreen. For these individuals, the The ability to issue voice commands and have the AI system understand their spoken input via robust speech recognition is entirely transformative. It enables hands-free operation and grants them full autonomy over the software. Speech recognition, or speech-to-text, utilizes complex acoustic and language models to accurately transcribe spoken phonemes into written data. When we integrate this capability, we immediately open our application's doors to a wider audience, fulfilling the responsible AI mandate that technology should empower everyone. Furthermore, this voice-driven approach is foundational for creating virtual assistants that can operate safely in environments where looking at a screen is impractical or impossible. By building applications that listen as well as they read, we bridge the gap between human communication and digital execution. To implement speech recognition programmatically, developers utilize the Azure Speech-to-Text SDK. Your Python code must initialize a speech config object using your specific Azure Foundry region and authentication keys. Next, you define an audio config object to capture the default microphone input. Finally, you instantiate a speech recognizer and invoke the recognize_once_async method, which captures the audio, securely sends it to the cloud, and returns the transcribed text payload. Observe the speech-to-text pipeline on screen. The user's spoken input is captured as audio, which then passes through acoustic phoneme modeling and language model processing. This sophisticated AI chain outputs transcribed text data, which ultimately grants the user hands-free agent action and total operational autonomy. While adding speech input is a massive leap forward, we must immediately consider the counter scenario to maintain true inclusiveness. What happens when an AI application relies heavily on audio output? The responsible AI training materials provide a highly specific, critical example. An AI agent that offers speech-based interaction should also generate text captions to avoid making the system unusable for users with a hearing impairment. This is a foundational lesson in inclusive design. If your conversational AI agent only speaks its responses aloud, you have inadvertently excluded the deaf and hard of hearing community. To solve this, developers must ensure that whenever the AI's language model generates a response, that response is simultaneously routed to a speech synthesis engine for audio, and to the graphical user interface as written text or closed captions. In media and entertainment scenarios, automated captioning powered by AI speech-to-text models can generate live or recorded captions for video streams. In enterprise environments, meeting transcription tools can display real-time captions for deaf participants, ensuring they have equal access to the ongoing conversation. Inclusiveness dictates that we never assume a single sensory capability. We must provide redundant, parallel streams of information so that the user can choose the modality that perfectly aligns with their unique physical requirements. This parallel processing of sensory outputs guarantees that no user is left behind, completely fulfilling the ethical obligations outlined by the responsible AI framework. Implementing real-time captioning in your client application requires a dual output coding strategy. When your generative AI model, such as GPT-4, returns a generated text completion string, your application code must simultaneously dispatch this string to the Azure Text-to-Speech SDK for audio playback, while actively manipulating the document object model to render the exact same text string onto the user's screen in a highly visible, accessible, and readable captioning container. This visual demonstrates the dual output strategy required for hearing inclusiveness. The AI-generated response hits a parallel routing node. It simultaneously triggers Azure Text-to-Speech for audio and UI DOM manipulation for visible text captions. Both streams merge to ensure total inclusive comprehension. Equally important to supporting users with hearing impairments is supporting users with visual or cognitive challenges. Inclusiveness demands that written content is universally accessible. The training materials highlight that applications can generate audio to read web content, articles, and documents aloud for users with visual impairments, and to support users with reading disabilities like dyslexia. This is achieved through speech synthesis, commonly referred to as text-to-speech or TTS. By integrating Azure Speech Synthesis into our AI solutions, we can programmatically convert dense, unstructured text into natural-sounding spoken audio. Modern neural text-to-speech models do not just sound robotic. They utilize advanced transformer networks to generate prosody. Prosody involves predicting the natural rhythm, stress, and intonation patterns of human speech. For a visually impaired user navigating an AI-generated report, hearing the content read with natural human inflection is vital for comprehension and cognitive retention. Furthermore, providing audio alternatives for text-heavy interfaces reduces cognitive load, allowing users to consume content while multitasking or resting their eyes. By defaulting to a design architecture where every single piece of generated text can optionally be vocalized, developers drastically lower the barrier to entry and ensure their intelligent systems are genuinely open to everyone. This seamless audio generation ensures that visual limitations never prevent a user from fully leveraging the powerful insights generated by your enterprise AI solutions. From a development standpoint, integrating text-to-speech involves capturing the text payload from your interface or language model and passing it to the Azure Speech SDK. Your Python script creates a speech synthesizer object. You can configure the voice characteristics, such as selecting a specific neural voice model. Then, by calling the speak_text_async method, the SDK handles the complex network communication and instantly streams the synthesized audio directly to the user's local speakers. The diagram displays the text-to-speech pipeline designed for visual inclusiveness. Dense screen text is fed through text normalization and linguistic analysis. The transformer neural vocoder processes this to produce natural speech synthesis, directly providing essential access for visually impaired and dyslexic users. Inclusiveness extends beyond physical and cognitive abilities. It also encompasses cultural and linguistic diversity. A truly responsible AI solution must reach global audiences and support multiple languages and regional dialects. If an enterprise AI application only processes and generates content in English, it actively excludes billions of non-native speakers around the world. To mitigate this, developers must leverage natural language processing or NLP to break down language barriers. The first technical step in this inclusive workflow is automated language detection. As users input text or speech, the AI system must instantly identify the language and dialect being used. Once detected, the system can dynamically invoke translation models or switch to a localized language model to process the user's intent accurately. Azure AI services, integrated through Microsoft Foundry, allow developers to build multilingual agents that seamlessly understand inquiries in Spanish, French, or Japanese, and respond in that exact same language with culturally appropriate context. Furthermore, automated speech translation can facilitate real-time communication between individuals speaking entirely different languages. By engineering our applications to be inherently multilingual, we respect the linguistic diversity of our user base and ensure that geographic or cultural background is never a barrier to accessing cutting-edge technology. Embracing linguistic inclusiveness transforms a localized software tool into a globally empowering platform, fundamentally aligning with the core promise of artificial intelligence to elevate all of humanity. To implement multilingual inclusiveness, your code must dynamically route inputs based on language detection APIs. Using the Azure Language SDK, your application sends the raw, unstructured text to a detection endpoint. The service returns an ISO language code, such as S for Spanish, alongside a statistical confidence score. Your application logic evaluates this JSON response and dynamically adjusts the system prompt instructions of your generative AI model to reply in the detected language. Here we see the logic flow for linguistic inclusiveness. Non-native user input hits the Azure Language Detection Service to identify the ISO code. The application then performs dynamic prompt translation and localized LLM inference, ultimately returning a culturally accurate response back to the global user. As we conclude our deep dive into the inclusiveness principles of responsible AI, we must bring our focus back to accountability and governance. The official training explicitly warns developers, always provide alternative input and output methods. Some users may prefer or require text-based interfaces, even when speech is available. Inclusiveness is ultimately about providing the user with choices and respecting their autonomy. It is the responsibility of the organizational leadership and the engineering teams to establish strict governance frameworks that mandate these inclusive design patterns from the very beginning of the software development lifecycle. You cannot retrofit true inclusiveness into a finished product. It must be architected into the core API interactions, the user interface, and the data processing pipelines. Thank you for joining this expert technical training session on building inclusive AI solutions. We hope this knowledge empowers you to develop applications that truly serve everyone, regardless of their physical, cognitive, or linguistic abilities. Please be sure to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep. At QuickTechie, you will find comprehensive Q&A banks, ebooks, audiobooks, advanced training modules, and interview guides to help you master these critical cloud concepts and advance your career. Build responsibly and build for everyone. By enforcing these rigorous standards at the organizational level, teams can confidently deploy intelligent systems that actively foster a more equitable and accessible digital world for all users. Accountability in inclusive software engineering requires rigorous automated testing and telemetry. Your deployment pipelines should incorporate automated accessibility scripts that scan the DOM for ARIA labels and verify that all visual outputs have corresponding text-to-speech fallback routines. Furthermore, comprehensive logging must track usage metrics across different interaction modalities to ensure that no demographic is encountering disproportionate latency or error rates in production. Our final flowchart maps the governance of inclusiveness. Organizational leadership establishes a governance framework that mandates alternative input and output methods. This forces engineering to architect multimodal APIs and implement automated accessibility testing, ensuring an equitable and inclusive AI system is deployed.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.